Okay, so we stopped on how to figure average speed, and so now we are on slide 10. So hopefully you're following along on your PowerPoints. And if you could go to the velocity slide. I had mentioned before that speed and velocity were pretty similar, that there is one difference. The thing about speed is that it basically just tells you how fast it's going. Okay, so right here, my pen isn't working for whatever reason. Probably because I need to actually hit slideshow. But see how it says that speed here is how fast it's going, whereas the velocity tells you that it's also going in a certain direction, so where it's going. Okay, so the speed is like 50 miles per hour, but velocity is like 50 miles per hour to the east. Okay, and it has some graphical representation here. It's showing you with these arrows. So like for instance, this one right here, it's showing you that it's going 30 kilometers per hour to the east. And so obviously the arrow is going to be pointing towards the east. And you can see on this one right here that it's going 60 kilometers per hour northwest. Well, notice the size of that arrow. Well, that arrow is twice as big. Well, it should be because it's twice as fast, right? So velocity is considered to be a vector, and a vector tells you not only how fast it's going, like the magnitude of it, but it tells you where, and that arrow should be represented as, you know, if it's faster, it should be longer. Okay? So velocity tells you not only how fast, but also where. All right, so now we are into acceleration. And acceleration is defined as the rate at which motion changes over time. So speed can change, direction can change, both speed and direction can change. Those are all things that can be considered accelerating. And then it can also be negative. So whenever it says that it can be negative right here, that just means that it could maybe be going to the west. And notice how that arrow is going to the left. Well, if you think about a number line, that kind of makes you think like it's going behind 0 or something. So that negative just tells you that it's going west, or it's going to the left, or it's going backwards. Okay? So you can see in this example right here, right? From this one right here, it goes from 30 miles per hour to 60 miles per hour. So does the speed change? Yeah, it gets faster, right? And on this one, it goes from 60 miles per hour to 30 miles per hour. So it decreases, but it's still changing. So it doesn't really matter if it's getting faster or if it's getting slower. Either way, if it's changing, it's considered acceleration. Now, when it gets slower, we usually say decelerating, okay? Now this one shows you that it doesn't change speed, but it changes direction. It made a curve. Okay, it was going like towards the left here, like that, but then it made this curve, which caused it then to go positive. And then you've also got where it could change direction and speed. So all of those things are ways to describe accelerating. Okay. I'm going to bring up the book really quick because I do think that it has an example that we can use this, which is going to give us like our average speed, where we can take the final velocity plus the initial velocity and just divide it by 2. And there's an example in our book that we can actually look at and see how that's happening. Okay, so I have to go to our book here. So we've already talked about velocity. And here, this is what I would like you to write in your PowerPoint. I would like for you, and I can't write on the book here, so I'm going to bring up the PowerPoint too, just so I have my PowerPoint right next to it, and you can sort of write what I'm writing. Okay, so either beside this one or this one, write acceleration is equal to final velocity minus initial velocity divided by time. Okay, this is your equation for acceleration. All right, and that little F just means final and little I means initial. All right, so it's giving you an example right here in the book. See if I can kind of make that a little bit bigger. Oh wow, when I did that it went all the way to force. That's not what I want. Sorry. Okay, so here we go. Saying that it's going from, if you read sort of this paragraph in the middle, it says acceleration due to a change in speed can be calculated as followed. And this is the equation that we just wrote down, okay? So it says if it's going from 60 kilometers per hour, and then the driver accelerates to 80 kilometers per hour, and it takes 4 seconds to increase the time, to increase that velocity, the change in velocity is what? Or the acceleration is what? Okay, now I'm going to do it a little bit different than they have it here, because I don't like that they have kilometers per hour and then they have time in seconds. So this is going to be a one where I need to actually write on an example here. Okay. And again, it moves it every time I do that. Okay, so we have acceleration. Here we go. Acceleration is final velocity minus initial velocity over time. So what was our final velocity in that case? So we went from 60 kilometers per hour. Oh gosh. Sorry guys. To 80 kilometers per hour in 4 seconds. All right, so our final velocity is 80 kilometers per hour minus our initial velocity, which was 60 kilometers per hour, divided by 4 seconds. Now this is where I'm going to change it a little bit, because I don't like that this is in hours and then the times in seconds. So do you think that there's a way that I could somehow convert that? Well, absolutely. I'm going to go ahead and put 4 seconds here, but then I'm going to drop down and I'm going to say, okay, how am I going to get 4 seconds to hours? Well, you can use dimensional analysis to do that. So if seconds is on top, then seconds can also go on the bottom so that they cancel. And then I'm going to go from seconds to minutes, and then I'm going to go from minutes to hours. Okay, so when I do that, my seconds cancel and my minutes cancel, and I'm going to be left with hours. But now I have to put some numbers in here. So for every 1 minute, there's how many seconds? 60. For every 1 hour, there's how many minutes? 60. Okay, and if I take my calculator here, just pulled out my phone really quick, and I'm going to get a really small number. It's like 0.0011 repeating. Okay, so I'm going to rewrite this now. I'm going to say 80 kilometers per hour minus 60 kilometers per hour divided by 0.0011 hours. Okay, and what happens is then I can take 80 minus 60 divided by this 0.0011, and I get this really big number. I get 18,181 kilometers per hour squared. Okay, so that's kind of what it's going to do whenever we get to another example here. I want to show you really quick every time. Guess I should have just left it small. Okay, so I want to show you this graph really quick. You can see that on this graph A, see how it's like a straight line? If I told you to take the slope of a straight line like that's going horizontally, does it have a slope? No, it's just a straight line, so there's no slope. So the acceleration would be 0. So just like how we did a distance versus time graph in order to find our speed or velocity in the previous video, you can do a speed versus time graph, and you can take the slope of that and you can find the acceleration. So like on graph B, it's showing you exactly what we just did, only it's not converting it like I did. It just uses seconds on the bottom. So it takes this point right here, this point right at the top, I can't write on it. So it takes that 80 kilometers right at the 4 seconds there, and then it also takes the 60, okay, and then it divides it by that total time of 4 seconds. So whenever we do our acceleration equation, we're basically finding slope. So if you feel like you don't know why you're ever doing slope in algebra, it really is used to find other things, you know, like speed and acceleration. There is an application to it. Okay, so I want to show you this next example really quick. But I am a little concerned about how much time I've spent on this one video, so I might actually stop this video and then start another one here in a minute. All right, so go to the next video and we'll do example 2.3 and 2.4.